Hello, class. Welcome to the second lesson, Rational Functions Part 2. I hope Part 1 was satisfactory and you were able to make some good notes. And thank you for our first online session. So, today, what I want to try to accomplish is kind of close the loop on what is a horizontal and vertical asymptotes and hopefully give you some ideas of when do we know we have a vertical asymptote and when do we have a horizontal asymptote. Look at some examples of transformations that we looked at in our homework. Hopefully you're able to get that, but if you still need some refresher, hopefully this series of exercises will help you. And then we'll dive into an in-depth work on asymptotes of rational functions because the ones that we're looking at are from our basic block functions, and obviously some of our graphs are going to be complicated. So we need to figure out how we address vertical and horizontal asymptotes. But that's the plan for today, and then we'll kind of put everything into perspective by sketching one of them. Okay, all right. So let's start today's lesson. So last class we ended up talking about horizontal and vertical asymptotes, and the definition we came up with was that if we have a line that was equal to 0, we call that a vertical asymptote. So we're looking at this line right here. Okay, so I want to make sure we generalize, well, later on we generalize it, but from the last example that we did on the 1 over x function, so this is 1 over x, we discovered that the line x equal to 0 was a vertical asymptote, and likewise y equal to 0 was a horizontal asymptote. And we said an asymptote of a function is a line, horizontal or vertical, that you get closer and closer to. All right. So the general case, let's look at the two general cases. The first one is a vertical asymptote. So we are saying that the line x equal to a is a vertical asymptote if y approaches positive or negative infinity as x approaches a from the left or the right. So if you think about it, if you're coming from the right of a, you're going in this direction. If you're coming from the left of a, you are going to positive infinity. Likewise, if you're coming from the right of a, you're going to negative infinity. And then if you're coming from the left of a, you could be going to a negative infinity. So let's look at these scenarios. If I label this A, B, C, D, then combinations of these could happen. It's possible that a graph could just behave like A, B, C, and D. It's also possible to have a graph behave like A and B, that when you approach A from the left, A from the right, y is approaching, both of them are approaching positive, the positive infinity. Likewise, it's also possible to have both happen in C and D, in the sense that as you approach A from the left and A from the right, you're both going to negative infinity. Or you could have a combination. Either you could have A and C happen. So, well, not A and C, but A and D happen, where coming from the right, you're going to positive infinity. Coming from the left of A, you're going to negative infinity. And you could also have B and C also happen. So different variations could happen. But I want you to what I want you to take away from this is that you are trying to find what happens as you approach what A from the left and the right. That only two scenarios could happen. Either you're going to positive infinity or negative infinity. Now let's look at the second scenario, horizontal asymptote. So horizontal asymptote is defined as the line y equal to b is a horizontal asymptote if y approaches b as x goes to positive or negative infinity. So if you look at the two scenarios, in the first one, if I call that A, as you go into positive infinity, it seems like you are getting closer and closer to the line B. Whereas if you look at example B, as you get closer and closer to x to negative infinity, then you can clearly see that y is approaching what is approaching B. So I have these questions for you, and then we can talk about it when we meet. How many vertical asymptotes can a rational function have? And then how many horizontal asymptote can a rational function have? And then can you cross a VA or HA? So I'm going to leave you to think about these for a while, for some time, and when we meet, we'll address these. But the answers are right here on the slide. So make sure you read the notes and see if you can find the answers to these three questions. So we know what horizontal asymptotes are. We know what vertical asymptotes are. Now let's do a little recap. So the ones that we're going to work on right now are functions that are transformations from 1 over x. So if we look at the very first one, it says I have r of x is equal to 2 over x minus 3. If I kind of factor things out a little bit, this looks like 1 over x minus 3, which kind of gives me a sense that this is a transformation of 1 over x. If I let g of x be equal to 1 over x, then all I see is I have a shift to the right, so I get x minus 3. So I get 1 over x minus 3, and then a stretch by 2. So I end up with 2 over x minus 3. So the graph of this is not that bad. All I know is that I'm starting with horizontal and vertical asymptote at 0 for x and 0 for y. And then what's going to happen is I'm going to stretch this. When I stretch it, the graph kind of shrinks, getting closer to the origin. And then I'm shifting this to the right 3 places. So if I'm shifting it to horizontal shift, I'm going to move the vertical line. That's going to go 3 places, 1, 2, 3. So right now it's supposed to be right here. My horizontal asymptote doesn't change. And then the graph kind of shrinks in that fashion. So I end up with that, and then that. And we can be accurate about where this location is when x is 0, y is 0, negative 2/3. So then that becomes the graph of r of x, which is 2 over x minus 3. Now let's look at the next example. The next example says s of x is equal to 3x plus 5 over x plus 2. So just as we did on last class assignment on the other video, this is a transformation from 1 over x, and I'm going to try and do long division to expose or to clean up this expression so I can see the transformation of 1 over x. So if I do the long division, I end up with x plus 2. We get 3x plus 5. This goes here 3. I get 3x plus 6. Divide. Subtract. You end up with negative 1. So this expression can be written as 3 minus 1 over x plus 2. So when I look at this, can you figure out where the transformation is coming from? It looks like it's a transformation of 1 over x that was shifted to the left by 2, reflected, and then moved up by 3. So if I look at it, I'm going to shift to the left by 2. So that's 1, 2. I'm going to move up by 3. So 1, 2, 3. And then I'm going to reflect. So on a regular 1 over x, I have something in the first quadrant and something in the third quadrant. So when I reflect, I know that it's going to look like that and that. Now the question is, we need to clean up this to be more accurate. So we know that we crossed. So let me be a little bit careful with my sketch. So I know that I'm going to cross the x and the y-intercept. So let's see. For x-intercept, what is that? So for x-intercept, y is 0. So I end up with, just looking at the numerator, 3x plus 5 is equal to 0. X is equal to negative 5 over 3. So I know that it needs to be somewhere here. Negative 5 over 3. It's a little bit after 1. So let's put it right over there. And then how about the y-intercept? Y-intercept, I have x is 0. And so that's 5 over 2. So we get 5 over 2, which is 2.5. So it's somewhere there. Okay. So when I sketch this, this is what I expect things to look like. That it goes this way, goes that way, and goes this way. So just trying to be a little bit accurate. It has to pass through those two interesting points. Okay, so that's what the graph is going to look like. But that's just because I could see the transformation of 1 over x by doing the long division. Okay, let's look at our next problem. So our next problem is 1 over x squared. That's f of x. So we remember this is one of our basic block functions, and if you think further, you realize the graph looks like something like this, something like that. So now let's use all our prior knowledge to try and arrive at this answer over here. So first of all, domain is x belongs to all reals minus 0. You can clearly see that there is no x and y-intercept. But when I look at the end behavior, if I look at horizontal asymptotes, if I pick horizontal asymptotes, it looks like as x approaches positive infinity, y approaches, so if you pick a very big number, when you square it, you're going to get a big number, so we end up going to positive infinity. Likewise, I go to x going to negative infinity. When I plug this into the equation, since I'm squaring, the negative turns to positive, so I have 1 over a very big number that goes to positive infinity too. So it looks like when I'm approaching positive infinity, oh, my bad, I did this wrong, I apologize. 1 over a very big number approaches, please pardon my error, it's supposed to be 0 and 0. So when you graph that function, as you're going to positive infinity and negative infinity, it looks like the graph should be tapering close to the line y equal to 0. The question is it above or below? That's what we don't know yet, but we know for sure that it's getting close to the line y equal to 0. So here we have a horizontal asymptote at y equal to 0. We could also look at vertical asymptote. So again, the only restriction on this domain is x cannot be what? So I'm guessing that x equal to 0 is the vertical asymptote, but let's check it and see. So if you pick a number really, really close to 0 from the right, so I'm looking at as x approaches 0 from the right, you could see that if you pick f of 0.0001, that is really close, you're going to square this. So you're going to get 0.0001 squared. That becomes a really, really, really small number that's going to positive infinity. Likewise, if you checked what happened with 0 from the left, if you pick negative 0.0001, that gives you 1 over 0.0001 negative that you're squaring. Now the negative turns to positive, you end up with positive infinity. So it looks like as you are approaching 0 from the right, y is approaching positive infinity, and as you approach 0 from the left, y is also approaching positive infinity. If you connect everything, it looks like as you approach 0, you are both going in this direction. So using my prior knowledge, we can clearly see that the graph looks like this. It's got a vertical asymptote at x equal to 0, that at y equal to 0, and you have this behavior happening at the near of 0, and then the end behavior behaving in this manner. So using my prior knowledge, I know that it's supposed to connect this way and that way. If you're not that convinced, use some test values to ensure that the graph is opening up both in the first and the second quadrant. But just applying my prior knowledge, I was able to come up with the sketch for this real quick. Lastly, let's look at, I think it was h of x is equal to 3 over x minus 2 squared. By inspection, if I pulled out the 3, this looks like a 1 over x minus 2 squared. That looks like a transformation transformation of 1 over x squared, which we just did. So 1 over x looks like this, with horizontal and vertical asymptotes indicated in the dashed line. So what is this function saying? It looks like you're shifting to the, you shift right by 2, and then this 3 is a stretch by 3. So I'm going to move this graph three units to the right, 2 units to the right. I'm right here now. The horizontal stays. And then now the graph just connects. So we got this going this way, and then that going that way. Since I crossed the y, I just need to know what's going on at the y. So in this case, when for the y-intercept, I'm looking at when x is 0, I am at y is equal to 3 over 4. So this location over here is what we are calling 0.3 over 4. Okay, so that is part 1 of today's lesson. We just went through some examples of the things that we probably saw in the last homework. Okay, see you in the next video.